Okay, let's talk about the basics of confidence intervals just to get started. So let's pretend that the distribution that we're going to be playing around with looks normally distributed like this. Just a regular old normal distribution. Sometimes it won't be that way, but that's okay for our purposes right now. Okay, so what the idea is, let's pretend that we are interested in the average number of donuts people eat per week. And okay, so the actual average we would call mu. Okay, because mu stands for the population mean, the population average. Excuse me. And let's say that that mu is 3.7. So the actual number of donuts that the average person eats per week is 3.7 donuts per week. Okay. And that's what we want to know. But in order to obtain that information, it's kind of difficult because you have to go ask everybody everywhere. And that takes a lot of time and money. It's just not feasible. So one thing we do is we say instead, well, what if we went out and got the mean of a sample? Okay. Let's say that our sample size is maybe 50 people that we ask. And the mean of the sample is 4.1 donuts per week. And then we could say, hey, look at this. About so the mean of the entire population is roughly 4.1. Now, of course, that's not exactly the 3.7. Certainly not. It's almost half a donut too high. However, that's one way to do it, and we've explored that in the past. Another way of getting an idea of what of estimating a population parameter is using what's called a confidence interval. And it works like this. First off, this number here that we are using to estimate the parameter mu, we're going to call that the point estimate. Okay, and that point estimate is going to be somewhere in the middle, okay, of the distribution. Now, it turns out it's going to be exactly dead center for the confidence interval that we create. And I know that there's still things are still vague in your minds. That's okay. Don't worry about it. It'll get clear. Now, the word confidence interval does include the word interval. So it's a good bet that our solution is not just going to be a single number like 4.1. It's going to be an interval, like everything maybe from here to here. Okay. And that's the way a confidence interval works. Now, we call this distance from the point estimate out to either end, we call that the error estimate, and we abbreviate it with the letter E. So once you have your point estimate right in the middle, then you go out a distance E to the right and a distance E to the left, and then that'll give you these two guys right here, and then that'll be your interval. Okay. Now, the good news is your calculator is going to give you those numbers. The formulas that are in the book and online and everywhere, they'll show you how to do all this by hand, but the formulas are in the book. Or, I mean, the formulas are in the calculator. And so you can just plug everything in and it'll just spit out the answer. And that's fine. I got no problem with that. So we know that this is 4.1 donuts. That's our point estimate. That is our sample statistic, our sample mean, that we are using to estimate the true population parameter mu, assuming that we don't actually know what it is, because that's how the world normally works. Furthermore, let's pretend that we used a formula, that we used the formula to determine what E is. And let's say that E is 1/2. Okay. So if I go out you know, if I go from the 4.1, if I go up a half, that puts me at 4.6, and if I go down a half, that puts me at 3.6. And you've done things like this in your own life, just without a fancy formula. You know, someone says, so, you know, about how many donuts do people eat per week? And you might say something like, oh, you know, I don't know, somewhere around 3.6, 4.6 donuts. Or you might say 4.1 donuts, give or take half a donut. And that's, you're doing a confidence interval. You're just not doing it explicitly, which is fine. Okay, now, there's, you know, working with confidence intervals is a little more scientific than just saying, yeah, 5 donuts, give or take a donut, or whatever. And so there's another feature involved. There's what we call a level of confidence. And usually the level of confidence is 95%. It doesn't have to be, but yeah, you'll find that in most problems that is the case. So the level of confidence, so we're going to say, hey, for this problem, the level of confidence is 95%. And so, okay, great. So what does that mean? Well, it means this, and this is how you'll write out your answers for confidence interval problems in this course. This little piggy right here means this. It means with 95% confidence, the true mean of the entire population is between 3.6 and 4.6 donuts per week. Or in other words, we are 95% confident that the true number of donuts that people eat per week is between 3.6 and 4.6 donuts. Now, did this confidence interval contain, or does this confidence interval contain the actual amount? In this case, yes. Yeah, 3.7 is between 3.6 and 4.6. Now, is that always the case? Does your interval always contain the actual parameter you're trying to estimate? No, of course not. But it often does. And so this is just a way of estimating a parameter.